Have you ever wondered what makes our smartphones smart or our computers able to, well, compute? It's a question that might seem simple, but the answer is anything but. The magic lies in the tiny components that make these devices tick. It's all thanks to these tiny marvels of engineering called microchips. These minute pieces of technology are the unsung heroes of the modern world. These little guys are the brains behind almost every electronic device we use. Without them, our gadgets would be nothing more than lifeless shells. From cars and airplanes to washing machines and even your refrigerator, microchips are everywhere. They are the silent workers that make our lives easier and more connected. But how do you make something so small yet so powerful? The journey of a microchip from raw materials to a functional component is a story of innovation and precision. It all starts with a humble grain of sand. It might sound surprising, but it's true. Yes, you heard that right, sand. The same grains you find on the beach are the starting point for the technology that powers our world. Sand is the primary source of silicon, the material that microchips are made from. Silicon is extracted from sand and then purified to create the wafers that will eventually become microchips. The process of transforming sand into a microchip is a long and fascinating one, involving many complex steps. Each step requires incredible precision and cutting-edge technology. Think of a microchip like a city. Just like a city has roads, buildings, and infrastructure, a microchip has pathways and components that allow it to function. It has roads, buildings, and a complex network of connections. These connections allow the microchip to process information and perform tasks. Creating a microchip is like building a city on a surface smaller than your fingernail. Imagine the level of detail and precision it takes to cram the infrastructure of an entire city into such a small space. It's an amazing feat of engineering and precision. Engineers and scientists work in ultra-clean environments to ensure that each microchip is perfect. So buckle up as we take you on a journey inside a microchip fabrication plant, also known as a fab. Here you'll witness the incredible technology and meticulous processes involved in making these tiny titans of technology. Get ready to be amazed by the science and technology behind the making of these tiny titans of technology. From grains of sand to the final product, the journey of a microchip is a testament to human ingenuity and the relentless pursuit of progress. Our journey begins with sand, which contains silica, the raw material for silicon. The silica is extracted and purified to create large ingots of almost pure silicon. These ingots are carefully sliced into thin, round wafers, thinner than a sheet of paper. These silicon wafers are the foundation upon which our microchip city will be built. But before we start building, we need a blueprint. Just like an architect designs a building, engineers design the layout of a microchip. This design includes billions, sometimes trillions, of tiny transistors, resistors, and capacitors, the fundamental components of electronic circuits. It's like designing a city with billions of tiny houses, all connected by intricate roads. This intricate design is then transferred onto a photomask, which acts like a stencil. The photomask is like a giant photographic negative containing the blueprint of our microchip city. Lights, camera, etch, creating the circuit pattern. Now comes the exciting part, creating the actual circuit pattern on the silicon wafer. This is a crucial step in the manufacturing process, where precision and accuracy are paramount. The silicon wafer, which is the base of our microchip, is meticulously prepared in a clean room environment to ensure that no contaminants interfere with the process. This is where photolithography comes in. Photolithography is a technique that uses light to transfer a geometric pattern from a photomask to a light-sensitive chemical photoresist on the substrate. It's like projecting the image of our city blueprint onto the wafer. Imagine a high-tech projector casting intricate designs onto a canvas. But in this case, the canvas is our silicon wafer. The wafer is coated with a light-sensitive material called a photoresist. This photoresist is crucial as it reacts to light, allowing us to create the desired patterns. Next, ultraviolet light is shone through the photomask and onto the wafer. The photomask acts as a stencil, guiding the light to form specific patterns on the photoresist. Areas exposed to the light harden, while unexposed areas remain soft. This selective hardening is what allows us to create intricate and precise circuit patterns. The soft areas are then washed away, leaving behind the hardened pattern of our circuit. This process reveals the intricate design that will form the pathways for electrical signals on the final microchip. It's a fascinating blend of art and science where every detail matters. Doping and layering, building the chip's architecture. This is where the magic happens, transforming a simple silicon wafer into a powerful microchip. Now that we have the basic circuit pattern, it's time to bring it to life. The intricate circuit design is just the beginning. We need to infuse it with the ability to perform complex tasks. This is where doping comes in. Doping is a fundamental process in semiconductor manufacturing, where we introduce impurities into the silicon wafer to alter its electrical properties. Doping is like adding different types of materials to our city to create different functionalities. Just like a city needs various buildings like schools, hospitals, and offices, our microchip needs different regions with specific properties. Impurities like boron or phosphorus are introduced into specific regions of the silicon wafer. These elements are carefully chosen to create regions that can conduct electricity or block it as needed. This process modifies the electrical properties of silicon, turning it into a semiconductor, which can conduct electricity under specific conditions. This is essential for the chip to function correctly. This is what allows us to create transistors, the building blocks of microchips. Transistors act as tiny switches that can turn on and off, controlling the flow of electrical signals. But a microchip isn't just one layer, it's more like a multi-layered cake. Each layer has a specific role and contributes to the overall functionality of the chip. Multiple layers of materials, including conductive metals like aluminum or copper and insulating materials, are deposited and patterned on top of each other. These layers form the intricate pathways through which electrical signals travel. Each layer adds another dimension to our microchip city, creating a complex three-dimensional structure. This 3D architecture allows for packing more components into a smaller space, increasing the chip's power and efficiency. As data flows through these layers, the microchip performs its designated tasks, from simple calculations to complex data processing. The efficiency and speed of these processes are what make modern electronics so powerful. In essence, building a microchip is like constructing a futuristic city where each layer and component plays a crucial role in the overall performance. This intricate architecture is what powers our smartphones, computers, and countless other devices. The journey from a simple silicon wafer to a fully functional microchip is a testament to human ingenuity and technological advancement. Each step, from doping to layering, is meticulously planned and executed to create the powerful chips that drive our digital world. Refining the chip structure. Now that our chip has multiple layers, it's crucial to refine its structure. This process involves polishing and etching to ensure that each layer aligns perfectly. Precision is key here, as even the slightest misalignment can affect the chip's performance. Advanced techniques like chemical mechanical planarization are used to achieve the desired smoothness and uniformity. It's like giving our microchip city a final touch-up, ensuring that every street and building is in its exact place. Testing, packaging, and the future of microchips. With the chip's structure refined, it's time to test its functionality. Rigorous tests are conducted to ensure that each chip performs as expected. Only the chips that pass these tests move on to the next stage, packaging. Packaging protects the chip and makes it easier to handle and integrate into devices. And looking ahead, advancements in microchip technology continue to push the boundaries of what's possible, paving the way for even more powerful and efficient devices.